Hi, my name is Kiran Baburaj. Welcome to Career Campus Pro YouTube channel. Today we are discussing Breadth First Search or BFS. By the end of this video, you will not just understand how BFS works, but also see it in action through awesome animations and visualizations. Imagine you are exploring a maze, but instead of going deep into one path, you want to check all the possible paths at your current level before moving deeper. That's exactly what BFS does. It explores the graph level by level. Let's break down how BFS works. We start at any node, usually at the root, and we will explore its immediate neighbor first. Then we move to the next level and explore these nodes. We keep a track of visited nodes to avoid the cycles. We use a queue to maintain the order of exploration. We begin at the node A and process it. We discover its neighbors B and C. And queue updates to B and C. Moving to the node B, we find B's neighbors, that is D and E. And next, queue processes the node C and discover its neighbor F, and it's added to the queue. And further processing the node D and the node E and subsequently the node F. So no new unvisited neighbors, so the queue becomes empty. The final path is A, B, C, D, E, F. So we have explored each level completely before moving deeper. Now let's dive into the actual code implementation of BFS in Python. Our function BFS takes two parameters, graph and a starting node. We start by initializing two crucial data structures. The queue, it will manage our exploration order, while the visited set prevents us from processing the same node twice. Next, we add our starting node to both the queue and visited set. This marks the beginning of our traversal. Next, we have the heart of the BFS in this while loop. We use pop of 0 to remove the friend of the list. This gives us FIFO, first in first out queue behavior. Each node we pops gets printed, showing our traversal order. For each node we process, we check its neighbors. This is where the BFS happens. We add all unvisited neighbors to our queue before moving to the next node. And for each neighbor of the current node, we check if it is visited. If not, we add it to the queue and mark it as the visited. This implementation ensures that nodes are visited level by level. Now let's summarize the key properties of BFS. The time complexity of the implementation is order of n plus e, where n is the number of nodes and e is the number of edges. This is because pop of 0 takes order of n time in a list. The space complexity is order of n for storing the queue and visited set. BFS uses a queue to traverse the graph level by level, ensuring the nodes closer to the start are visited first. This is particularly useful for finding the shortest path in an unweighted graph. And other applications include level order traversal in trees, network broadcasting, and solving the puzzles like shortest path in a maze. So that's all about BFS. If you found this video helpful, don't forget to like, share and subscribe for more programming and algorithm tutorials. Happy coding, thank you.